Why is there more matter than antimatter in the universe? This question has fascinated scientists and astrophysicists for decades. The language of physics might seem complex, but let's dive into the world of particles and explain in a clear and relatable way why matter appears to be more prevalent than antimatter. At its core, the universe is all about balance. We exist in a delicate equilibrium of forces, particles and energies. Matter is everything we see around us, from the trees to the birds to the stars. Antimatter, on the other hand, is a curious counterpart, almost like a mirror image of matter. For every particle of matter, there exists an antimatter particle with the same mass, but an opposite charge. When matter and antimatter particles come into contact, they annihilate each other, turning into pure energy. So, if there were an equal amount of matter and antimatter in the early universe, wouldn't they have simply cancelled each other out, leaving us with a universe devoid of both? This is where the mystery lies. Something must have tipped the scales towards matter. Scientists believe that in the first moments after the Big Bang, when the universe was a seething soup of particles and energies, a tiny difference in how matter and antimatter behaved determined our existence. Through a process called CP violation, it is thought that a subtle asymmetry emerged, favoring matter over antimatter. This slight preference allowed matter to survive and form the building blocks of galaxies, stars, and ultimately, life itself. To unravel this intricate puzzle, physicists have conducted numerous experiments. One such experiment involves studying a particle called the B meson. By observing the B meson and its antimatter counterpart, the anti-B meson, scientists hope to uncover the elusive mechanism responsible for the matter-antimatter imbalance. Another fascinating area of research involves neutrinos, enigmatic particles that barely interact with matter. It is hypothesized that neutrinos may hold the key to understanding why the universe has an excess of matter. With elaborate detectors buried deep underground, scientists are diligently studying neutrino behavior to shed light on this fundamental question. While we still have much to learn, the current consensus among scientists is that the matter-antimatter asymmetry is a consequence of fundamental particles and their interactions. The discovery of the Higgs boson at CERN's Large Hadron Collider was a significant step forward in unraveling the secrets of the universe at its most fundamental level. Ultimately, the question of why there is more matter than antimatter is not only a scientific puzzle, but also a philosophical and existential one. It forces us to contemplate the very fabric of our existence and the delicate balance that allows us to be here today. As our understanding of particle physics and the cosmos continues to evolve, scientists worldwide are driven by an insatiable curiosity to find answers. Every new experiment and discovery brings us closer to unraveling the mystery of why, against all odds, there is more matter than antimatter in the vast expanse of our extraordinary universe.